Hi, I thought I'd make a little quick video about a project I'm working on. The Pix Hawks that I have used on my automated mower, such as this one, the old Pix Hawk 1, I guess it's called, at 2.4.8. I don't know, the numbering scheme always confused me, being kind of late to the game on all this. But anyway, I have a couple of these bought different times from different vendors, Chinese knockoffs, I guess you might say, because they're not made by the original manufacturer anymore. But got pretty good service from one of them. The other one always was a little flaky, but both of them have kind of stopped working properly now. I'm pretty rough on them because I put them on this mower that's out in the sun in the summer for hours, all day long working, so it gets quite hot. I do have it ventilated, no lid on it when I'm doing it. But anyway, they don't, they get kind of rough service, bouncing around, you name it. So anyway, I'm in the process of replacing that, and I thought I would try a Kakute F7. So that's what I've bought, and if you are familiar with that, you know that it. Well, let's see. I'm going to minimize my myself off the center here. There we go. This is what it looks like in a blown up view. This is the F7 AIO. The regular F7 is this version. Notice it has nice pads for all the connections other than the motors. But when I say pads, I mean through hole that you can put a wire, easily solder a wire to. The AIO, they did away with that bottom connector, and you have things, just pads to solder to. The one that's really tricky, or I just don't quite understand why they made it so tiny, this SCL and SDA, the I2C connections that are used for the compass, man, those are incredibly tiny. You can't really tell it from that view. I'm gonna pop back my big screen back up here and let you see, maybe if you can. I doubt you can really tell, but this is the actual board. If it would focus on it, I'd love for you to see what that looks like. There we go. Look there at the top. Those tiny pads are what you have to solder wires to get the I2C. Boy, that's something. And anyway, I understand on a drone where you need minimum weight, minimum everything, but I've got plenty of room, plenty of weight capacity. So boy, I'm not real crazy about this board, but it is a good price, and I guess gets good reviews, so I've got it. So that's what I'm going to use. So what I have done, I'm making a carrier board, and I'm talking quick and dirty because I really want to get it going. One day maybe I'll make a nice one that would be useful for other people, but I'm planning to even make this in-house here with toner transfer method I've done many times. It doesn't make a lot of sense to use it much these days because PC boards are so inexpensive and pretty fast but to get made. But still, there's something great about once you get a design done, you spend days working on it. When you get finished, then you still got to wait at least a few days to get a board, whereas if you make it at home, boom, you can have it in a hurry. But anyway, so I'm going to make this one at home just because I want to get it going quickly. And I use the auto router in Eagle to make it, which is not the best thing always. I do use it most of the time, but I do a lot of tweaking and playing. This one, I just kind of let it do it, and it's going to be done. But what I've done is I'm going to have to solder wires again to some of the connectors on the F7 AIO, which is this in the middle, and come out to pads that I then have the PC board routing to connectors. And because I'm not sure, I like terminal blocks. These are going to be terminal blocks that I can use, or instead I can use the standard DF13 JST connectors for the telemetry, all the serial ports on this side. Let's see, this is that's the I2C port on this side, I think, yeah. And these are the servo outputs over here. This is power coming in. This is servo power coming in because I'm using some heavy-duty servos that I run off 8.4 volts. So anyway, this is my board I'm making. This is the quick schematic. It's not even well done. I could have connected things together. I just used labels to label it. But anyway, just thought I'd show you that where I'm at the stage I'm in now. Well, just one more detail. I started out by creating the spreadsheet with all the signals and what the equivalent, let's see, somewhere on here, the equivalent on the Pixhawk, and where they are on the F7. So basically, for instance, you know, the autopilot serial 1, telemetry 1 on the Pixhawk is UART 1 on here. So I've got all that labeled. I highlighted in yellow the ones I wanted to definitely get on this board, so I'm not doing everything. Some of these I could have done without as well, but it was easy to do. I'm going to put the buzzer, and even I did actually wire the LED. I brought it out to a connector as well in case I want to put an LED to indicate status. So it ended up like usual. I probably put more into it than I had planned, but it's still quick and dirty, and we'll see what happens. So I'll let you see things as I move along with the project.